at today. We're going to look at direct variation again, get their numbers correct here. So we're going to look at direct variation first. And direct variation, I'm not going to spend a whole lot of time on it because we've already kind of done some of that anyway, pretty much. And then we'll do inverse variation. That's the big thing we're going to look at because that's something new we haven't really talked about. Okay, so very first thing, we're going to again direct will be very small. We'll do just a little bit with it, and then after direct variation, we'll show you what inverse variation is. Go from there. But the biggest thing with direct variation, yeah. Okay, so a direct variation basically is this: as one variable increases, or again, could be that it decreases. Then basically we're going to do this. We're going to have it so another variable does the same thing. And for these, we're going to look at some equations. They're going to be kind of short as we're going through these. But basically, direct variation. If you've got one variable that goes up, a second variable goes up. If one variable goes down, another variable goes down. So they're always moving in the same direction, if you want to kind of think about it that way. And basically for this one, the basic general generic equation, sometimes they call it a standard equation. You can call it whatever you want to call it here. Is y equals kx. Okay, and this doesn't really make sense, but when they talk about the k here, in this case, the k is the constant. Why it wouldn't be c, I don't know, but somebody called it constant was k. Probably goes back to something that was like some other language. They changed things 400 or 500 years ago, and who knows what it was, but that's just what it is. So, all right. So the big thing on this one, you've got to be able to find what this constant or this k value is, and for a direct variation equation, your k value is you're going to take the y value and divide it by x. And this is one of those things. Y'all have done this like forever. Y'all, nobody just ever called it that, but there's an equation that y'all work with, y'all done with. They never called it a direct variation equation, but probably they should have just to kind of give you an idea of what's going on. What's the probably one of the most famous equations we've got? What's the formula for area of a circle? Area equals pi r squared, right? Everybody remembers that one, right? That's a direct variation equation because what happens if you make the radius a little bit bigger? What happens to the area? It gets bigger, right? If you take the radius of a circle and you make it a little bit smaller, the area will get smaller. So this is one of those things that way, way, way back when, if you need like an example of one, area equals pi r squared, that's an example of a direct variation equation. If you make the radius a little bit bigger, then the area also gets bigger. If you want to take your radius and make it a little bit smaller, then the area also gets smaller. And for this equation, your pi value here, that's your k value, which again, pi being what it is, that's 3.14. So no matter what you do on any equation like that one, pi is always 3.14. That's the constant. That's the one thing that doesn't change for any size circle. Pi is always pi. It's always 3.14159, all that decimal stuff that's up there. So that's kind of what you want to think about when you're thinking about a direct variation equation, that it's some number, some area equals some constant times, some other variable that you're working with. So that's always the best example I can think of when we talk about direct variation equation. Because again, that's one everybody says, oh yeah, it's pi r squared. Because again, if you want to make the radius get smaller, that makes the area get smaller. And they always kind of follow each other as you go back and forth on this. Now, one thing they will actually do is they're going to ask you to, and maybe getting a little bit. Actually, let me show you this other thing. So that's direct variation equation. Here's the big one that we're going to do. This is the kind of big thing we're looking at. This is the big thing we're going to deal with today is inverse variation. And inverse variation basically is just the opposite of what we're talking about back here with direct variation. So inverse is basically this. So for inverse variation, as one variable increases, another variable decreases. So direct variation, both of them go the same direction. Inverse variation, the inverse is like opposite, reciprocal, if you want to think about it that way. So if you got one that gets bigger, the other one gets smaller. They kind of go back and forth on those. Okay. And your inverse equation is y equals k over x. So direct was directly beside it. Inverse is going to be the opposite. Instead of being beside it, it's going to be underneath it if you go through that part of it. Okay. If you have to get the k value for this one, then your k value, and again, k is still your constant that we were talking about. Same thing back here. K in this case is going to be x times y. Okay. And best thing on this one, and I don't have like an actual example because it's a little bit different on this one. But best case scenario I can think of on this one is if you, let's say, fill in the blank favorite person you want to see, favorite group you want to see in concert. How many people would go pay? Let's say they're going to be here in Huntsville. How many people would be willing to pay $500 to go see their favorite person in concert? Oh, who would? All right, a couple of you, right? All right, tickets are $500. One or two people like, yeah, I'd do it. All right, what if I told you tickets were $5 each? How many people want to go down? Wait, what? Just the opposite, right? So $500 tickets. We got this many people want to go. So then I say, all right, if I take the price from here and drop it down here, now everybody wants to go, right? So those things you got to kind of going back and forth on that. How much driving do you do when gas goes to $4 a gallon? If it were to go to $4 a gallon, not as much, right? So price of gas goes up, your driving goes down because you don't have as much money to kind of drive on that one. So inverse variation is basically that. If something goes up, it's going to make something else go down. And I know I don't have any seniors in here, but in my juniors next year, when y'all take econ, you'll talk about inverse variation a lot because that's a big thing in economics. That it's you're trying to find that happy medium where that you get things to kind of balance out on that part of it. So I know, and I'm not a big Rolling Stones fan, but when they had their farewell tour, ever how many years ago, the nosebleed seats were $500 each. Like front row tickets were like $10,000 or $20,000 because it was their farewell concert, all the stuff they were doing, and so it was just ticket prices were outrageous. Like I say, I'm not a big Rolling Stones fan, but even then it was like, wow, that's a lot. So, okay, so what's going to happen on some of these is that some of these problems you're going to have a table of values, and we're going to basically do this. Let me start on another page here. we'll just say it this way. Determine if the table represents a direct, inverse, or neither variation. And we're going to find the k value. So I'm going to give you a little chart of numbers on this one, and we're going to figure out if it's direct, if it's inverse, and then we're going to find out what the k value is going to be. So, and again, it could be direct, it could be inverse, it could be one that doesn't really do anything at all. It's just, it may have a pattern of numbers, but it doesn't really fall into either one of those two categories there. Okay, so here we go. Let's do this. Let's do Okay, so we'll start off with this one. All right, and basically we'll actually do the answer first here. We're going to find the k value first, and then we'll use that to figure out whether it's going to be inverse or direct or whatever it's going to be at that point. All right, and if they give you one of these, here's the easiest thing to do for this thing. Very first thing we're going to do on all these, on every one of these tables, is we got to figure out what the k value is first, and we're going to start off doing x times y. If you multiply x and y together and it's the same, then we're good to go. If they're different, then we'll try the division and go from there. So we're going to try out inverse first to see if it works. We're going to do k equals x times y. If that works, we're good. If not, we go on to something else. Okay, so if we do x times y, 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. 4 times 3 is 12. So every single time we get the exact same number. So if every single one of these numbers is the same, well, then we've got k equals 12. We know it's the same number every single time we got that. And again, if you multiply x and y together to get the k value, that means it's an inverse equation. So they ask you, what's this thing going to be? That's going to be an inverse. Oh, now if they do this one, and we didn't do this earlier, but we'll talk about this one. If they ask you for an equation, that means you just plug in the k value. So finding the k value is pretty easy. Just multiply them together. Again, if you multiply them together, that means it's inverse for that part of it. And as far as the equation goes, all we're going to do is we're going to take this equation we got for inverse, and we're going to put 12 in for the k. So they ask us to find out what this value would be. We're going to do y equals 12 is there. And then that would be your basic equation that you're looking for. Okay, so we're going to start off doing x times y. If you do x times y and all the numbers are the same, we've got our k value, and as long as you're multiplying, that makes it inverse. And again, if they ask you to write an equation, if we know it's inverse, then we're going to start with this. The only thing you've got to do is you've got to write down what this k value is. In that case, the k would be 12. Okay, let me give you another one where it's not inverse. We'll check it first and see, and then we'll go from there and kind of show you the next step to do if it's not an inverse equation. Okay, so for this one, new table numbers. So we got 0.2, 0.5, 1, and 1.5 for X. We got some decimals. For Y, we got 8, 20, 40, 60. Okay, and again, usually multiplication is easier than division. So anytime we're doing these, we're going to check the multiplication first. So we're going to do X times Y and see what we get. And if everything is the same, we're good. If it's not, then we're going to go back and try division and see what we got going on. Hey, Rochelle. Over here. Hey. Can you wait on that? Can you wait just a little bit to finish that? Okay, thank you. All right, so go ahead and multiply them out. If you do 0.2 times 8, that is 1.6. And you can jump over here and you go, well, if I do 1 times 40, that's 40. So you're getting 1.6. You're getting, if you do 0.5 times 20, that gets you 10. So you got 1.6, you got 10, you got 40. So X times Y doesn't work because, again, if this thing is going to work, all the numbers have to be the same. So then next time we're going to try K, and now we're going to go back and see if it's direct, which means for the K value, we're going to do Y divided by X and see what we get. So for this one, we're going to take 8 and divide it by 0.2. If you don't trust doing it in your head, that's where you just take out a calculator and just check your number real quick. If we take 8 and divide it by 0.2, that is 40. Okay, if we take 20 and divide it by 0.5, also get 40. So you're like, well, if we get the first two the same, do we have to keep going? Yeah, you do, because sometimes the back numbers may not work, so you may get one or two that do. This one's easy. That's 40 divided by 1. We know that's 40. So the last one we got to check is the 60 divided by 1.5. That's also 40. Okay, so they ask you to check them. Again, you try multiplying the x's and y's together, see if that comes out the same. If it doesn't, then we cannot do multiplication. So now we're going to try division. If we try division and all the numbers are the same, well, we know that's k equals 40. We got the k value. And again, if division works, to get the k value, that was y divided by x. That means it's got to be direct. And same thing, if they ask for you to write an equation of it, you go back to the same equation we had, the y equals kx. But again, you just plug in the 40 here. Oh, can't see that, can you? Okay, so we got direct. So equation, the basic generic equation was y equals kx, but this time you just got to put the 40 in. So it would just be y equals 40x. Okay, so again, take all the x's and y's, try multiplication. If the numbers are the same, that's great. If it's not, you go to division. If all those numbers are the same, that's great. And we got it. Now, if these have been different numbers, if multiplication and division, if you check both of them and neither one of them works, then that's where you would just have to come back and say that it's neither. It's not direct. It's not inverse. It's just some other something that somebody's made up that doesn't really fit in any categories. So. Okay, but again, most of that's just going to be having your calculator and kind of working with it and just knowing what all is going on with it there. Okay, so there's the first kind of half of what we're doing today. Just figuring out whether something is direct and inverse or based on the graph, either neither. But again, it comes back to either one of those two equations, either y equals kx or y equals x over k. And this one, you can think about this as like, and how this is kind of similar to some stuff we've done before. This is kind of like y equals mx plus b. So this is kind of like when we did slope, that the k is kind of like the slope, if you want to think about it that way. So that's kind of where this is from. This is something new we haven't done yet. We're going to show you how this graph works today, but this graph actually is still pretty easy too. So. All right, so here's the last thing for today. Doing a little bit of graphing, and again, it won't take too long. because once we kind of walk through the first one, we'll get through the rest of it here. So. Okay, new word for the day. And just don't think we've ever talked about this one. I don't think you would have talked about this in Algebra 1, so this should be like a brand new word that's kind of popping up here. Asymptote. Basically for this one, asymptote. This is a line that you get close to, but you never touch it. It's kind of, like the electric fences that, like if you watch Jurassic Park, you remember the big electric fences they would put up to keep the T-Rexes in their cage or whatever it was, animals, whatever dinosaurs they're working with. Asymptotes are kind of like that. You can get close to them, you just don't want to touch them. So you can think about an asymptote being like an electric fence. It's something that you can get close to it, but you don't want to touch it because then it's going to shock you when it comes off this thing. And there's basically two types we're going to talk about. The first type is a vertical asymptote. And just so we don't have to say vertical asymptote every time, we'll just say VA, just to make it short. So that's a vertical line, that's going up and down these. For the things we're going to look at, these occur where the denominator equals 0. Okay. And so again, vertical asymptote, that's basically just a vertical line. And if y'all remember when we graphed all the quadratic stuff, we would do like a line of symmetry. It was always a vertical line. This one's kind of almost exactly the same thing on this one. So anytime you're doing this one, when you're doing a vertical asymptote, the equation for this thing is always going to be x equals some number. And finding the number is really easy. It's not one of those things where you gotta look really hard for it. Finding out the number that you're going to use here for your vertical asymptote is really, really easy. So that's not a big deal. All right. Your horizontal asymptote. Again, HA for short, just so we don't have to worry about, saying horizontal asymptote every time. So when we're doing these, like on the test, I may just put HA and VA so you can see what they are. Basically on these occur when you add or subtract a number outside of the fraction. Okay, so again, vertical asymptote, and again, these are all kind of going back to the inverse variation equations, which were fractions. So this one, we're basically looking at fractions. So vertical asymptote, that's where your denominator is going to be equal to 0. And your horizontal asymptote, this is where you're either going to add or subtract a number that's on the outside of the fraction. Okay, in vertical asymptotes, you're going to be x equals every time. Horizontal asymptotes, they'll be y equals every single time. And again, finding these two numbers is going to be really, 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 really easy. We just got to know what they are and just kind of how to get there as we go through these things. Okay, so I'm going to kind of give you the short version for this one, and we'll kind of see how this will go from here. All right, so we're going to start with, and in a second, y'all just kind of watch it. In a second, we'll come back and kind of condense this thing down so it'll go a lot quicker. So we're going to start with this thing right here. And here's what we'll do. Go ahead and write this part down. So we're going to graph y equals 4 over x. And we're going to skip the work. I want you to see the work. We're not actually going to do it because this will speed this part of the work up a lot here. So we don't have to spend as much time writing everything down. But basically, that's the problem that we've got here. Okay, and we said vertical asymptotes, that's where the denominator is going to equal 0. Horizontal asymptote, that's where we've got a number that's added on the outside. Well, in this case, if we take the denominator set it equal to 0, that would just be x equals 0. And that would be our vertical asymptote. For the horizontal asymptote, there's not a number added out here, right? So if there's nothing out there, then that basically would just be a 0. Okay, so that's how easy it is to find the vertical asymptote and the horizontal asymptote. This one, it's this thing equal to 0. If there's any number out here, that would be your horizontal asymptote. If there's not a number, then we're going to put it at 0. Now, here's what we're supposed to do. And this is the part we're going to kind of skip over this one. Because we're not going to do this for all the rest of them. We're just going to do this so you can kind of see what's going on. But this would be one where we would make a table of values. And again, do not write this part down. Let's kind of watch. This is where we take a table of values. We plug in 1 for x, and we'll do 4 divided by 1, which would be 4. And we'll plug in 2. 4 divided by 2 is 2. We've got that. Now, we're not going to worry about 3 because that would give us a decimal number. So we're going to do 4. Do 4 divided by 4, that would be 1. We are going to pick one decimal number, but one that's easy. We're going to plug in 8. So that's 4 over 8, which is basically a half, which as a decimal number would be 0.5. All right, and if we graph those points, it would look something like that. So here's what I want you to do. Now, the graph part on this one, this is where I do want you to go back and draw out a graph real quick. The graph on this one, and we'll get it just a second before we do that one. But basically, if we graph those points, here's the 1, 4. There's the 2, 2. There's the 4, 1. And then this would be that 0.5 that's way back over here. And we'll redraw that here in just a second so you can see it. And then we're going to do the same thing for these numbers, but now we're just going to make them negative. But if you take 4 and divide it by negative 1, the only thing that's going to change is the answer is still going to be 4, but now it's just going to be negative 4. So if we make all these numbers negative, it takes all those exact same answers, but just changes them from positive to negative. All right, now here's where we get to kind of see the asymptote. This one may be a flashback to way back when back here. But if you plug in 0, what's 4 divided by 0?
0.
Are we sure? Oh, get that nice little divide by error message, which means it's not 0. I mean, if we're doing slopes, we said you could have 0 or you could have a no slope. Well, in this case, it's not slope, it's a number. So this would be one where we would say that number would just be undefined. It doesn't exist, and that's why we get those asymptotes that are going there. So when we graph these things, so here's where we'll kind of do it real quick. So if we graph y equals 4 over x, and again, we're going to skip all that table of values that we had here. And this is the main thing you need to know, that if you're graphing one like this, and this number could be 4, it could be 2, it could be 3. It doesn't really matter what the top number is as long as it's here. As long as that's a positive number, it's going to be there and there. And again, we get those numbers from basically making a chart where we would do all that, but we're not going to do that because we're going to know as long as this top number up here is positive, we're going to do this every single time. All right, and again, for this one, we said, now here's where the asymptotes would come in. The asymptotes would look something kind of like this. That basically we've got one on top of, we got one at x equals 0 and y equals 0. So the dashed lines here, these would be like your electric fence that you don't want to touch because there's, you got a T-Rex inside of it. So that's your line, that's your asymptotes you got here. This one's a side to side asymptote. So it's horizontal. So it's going to be y equals 0. This one that's going up and down, that's a vertical asymptote. So it's going to be x equals 0. Okay, and the good news is you are not going to have to graph when we do these questions. You are not going to have to graph the points and plot all these points out like this, because we're just going to basically know, all right, if we've got these graphs, this is kind of what we're looking at. All right, oh, now one thing we haven't talked about in a while, domain and range. So basically every number is good, but again, because we get these undefined numbers that's at 0, which is where the asymptotes are, basically for this one, for the domain, these are x values. We can say that it's all real numbers, but we're going to skip over x equals 0. So x cannot equal 0. For the range, we're going to say the exact same thing, that it's all real numbers, but this time it's y cannot be 0. Okay, so as long as the 8, and we'll show you this here in a second one, but as long as this top number is positive, it's always here and here. If we took that exact same graph, but made it -4, again, you can just do kind of a quick sketch on this one. We don't have to get like super fancy on this one. If that was -4 over x, it's the exact same graph, but instead of it being here and here, it's going to be in the other two corners. If we do -4, it's going to be here and here. Okay, so positive, it's those two corners. If it's negative, it's the other two corners. And that's all you got to remember as we're doing these. So if it's just a number over x, if that number is positive, it's those two corners. If it's negative, it's those two corners. Whether that's 14 or 40 or -43 or whatever it's going to be, it's always the exact same graphs. You're not going to have to plot 15 different points to do this. You just need to know where is this thing going to be based on whether this thing is positive or negative. Okay, and then the last one we'll do, and this will be how easy it's going to be. That here's where they're going to start moving the graphs around a little bit. That we'll do kind of like we did when we started doing quadratics way back when. When we graphed quadratics, we started off with it being like right at 0, 0. And then after we had the quadratic, we started moving it up and down and left and right. This one's going to be that exact same thing. That we're going to start with these, get some easy ones, and then you're going to have one or two where you're going to have to move them up or down or left or right for this one. Okay, so here's where we're going to do the transformations. And these are going to be like easy. Again, it's not going to be real hard, so it should be pretty straightforward. Okay, so it's going to be y equals x minus h plus k. And y'all remember how when we did the, and I'll slide back over here, when we're doing the quadratics, how if you had some number, how we did that? We did x minus h squared plus k. We had a number on the inside of the parentheses. We had this k on the outside. The big difference on this one is this time, the h, instead of being up here in the parentheses, now it's in the denominator. So if you've got an h that's in the fraction, that's your opposite horizontal movement. Opposite horizontal. So that's how much you move in the opposite horizontal direction, whatever this h number is that's here. And then your k number that's here, that's your vertical movement. and it's not opposite. It's, just like if it was +2 when we were doing quadratics, you moved it up or down. If it's +2, you move it up 2. If it was -2, you move it down 2. So it's still that same thing. It's still that same thought you want to kind of think through. That it's moving it, whatever's in the denominator. This is the horizontal movement, opposite direction. This one's going to be your vertical movement. Okay, we'll do one graph, and then probably once we do one, everything else should be okay. So we're going to graph it. We're going to name the horizontal asymptotes, the vertical asymptotes, and the movement. So we'll do the up, down, left, right, just to make sure everybody's good. Everybody's good on that part. And we're going to talk about domain and range. And again, domain and range will be easy because it's always going to be all real numbers except for, and then we're going to leave out a couple of different numbers here. The first thing is it's a positive number over x. So if it was like that, if that's all it was, we know the graph would be like that. It'd be here and here, being on the top two corners. So for this part of it, we got that part here. The -3 that's here, that tells us how much this thing is going to move. So I'm just going to draw it through here. So that means it's going to be 3 in the opposite direction. So -3, you normally think it's to the left. This time we're going to say that's 3 spaces to the right. The +2 that's here means that's going to go 2 up. And again, it's just like when we did the quadratics. The numbers there's nothing weird about the numbers. You just look at it. The number in the denominator, it's 3 left to right, opposite direction. The number that's out here, that's your up or down. And once you've got these two numbers, that's your vertical asymptote and your horizontal asymptote. So once you've got this 3 right, once you use this number, that's your vertical asymptote. So your vertical asymptote is, again, basically you take this thing and set it equal to 0. But if you do that, you get x equals 3. But again, if you move it 3 spaces to the right, you're at a +3. So you'll change it, just like when we took it in or out of the parentheses, you change the sign. Same thing here. You change that sign from -3 to +3. Horizontal asymptote, you don't do anything with that one. You just say it's just y equals 2. Whatever that number is, that's your horizontal asymptote. So that number is your vertical asymptote. That number is your horizontal asymptote. Okay, again, that's your movements, 3 right, 2 up. And we'll get the domain and range here in a little bit. Well, I guess we'll go ahead and do that. All right, we'll say it's all real numbers except for, and then you just say x cannot equal this number right here. So it's everything except for x equals 3. Just put a slash through that to get that one. And then your range, that's all real numbers except for y cannot equal 2. Because again, these are the x equals 3 and the y equals 2. Those two things, that's your fences. That's what you do not touch because that's where your T-Rex is. That's where your velociraptors are, whatever it is. That's the fence that you don't touch because you got to stay away from it. So that's the two things you're staying away from. So when you graph this one, I don't have room to graph here. Here's how easy the graph is. Instead of starting at 0, 0, we don't really need the rest of that. So here's how easy you do for the graph. And I'll pull this back in a minute. For the graph on this one, instead of starting at 0, 0, we don't start at 0, 0. We're going to go 3 spaces to the right and 2 spaces up, which would put us here. And basically now that's the center of everything we're going to do. So we're going to draw a vertical asymptote through that point. That's at 3, 2. And we're going to draw a horizontal asymptote. So again, instead of starting at 0, 0, You're going to go 3 spaces right, 2 spaces up, and then you're going to draw basically an X or a T through that point. Draw a vertical line, horizontal line. And then the only other thing you're going to do then is, since this top number up here was positive, we're going to put it there, and we're going to put it there. And you will not have to, all those choices. Those are all going to be multiple choice questions when you graph these. So you're not going to have to graph those, because it's just a matter of just finding them in the right spot. What I'll have is, I'll have questions that, instead of being at 3, 2, I mean, you have it here. Then I'll have another one where it's got graphs in the negative part. So it'd be here and here. I'll have another one where it's at negative 3, 2. So it's over here. There might be one that's at 3, negative 2 down here. So it's just a matter of moving the asymptotes so they're there in the right spot. So the graphs will be really easy. All the graphs are going to be multiple choice on the homework, because it's too hard to graph and do all that. So it's just making sure that you know that, again, that the bottom number tells you how much to move left or right, opposite direction. The other number out here, move it there. If you don't have either one of those two, it's just still at 0, 0 as you go through those parts. All right, so there's that last little bit we were doing to get the graphs out.